Hello everyone, I'm Irene and I'll be taking you through what I've learned from the Machine Learning Diploma with Allison.com. Starting with the definition, you'll find that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And you have the two different types of machine learning. You'll find that there is supervised learning, which is a type of machine learning that requires a human labeled data set which provides the necessary supervision during training a machine learning algorithm. Then the unsupervised machine learning enables a machine learning algorithm to learn without any supervision. As we are going to see the types of supervised machine learning, where we see the regression. And here, this is a continuous data type of numerical data, for example, the price of a house, and the target value is a numerical variable. Then we have classification, which is a categorical data, for example, true or false, differentiating cats and dogs, or differentiating emails. And then the target value is a categorical variable and it is discrete in nature. We also have the types of unsupervised machine learning, where we have the clustering, where we group together features that exhibit the same characteristics. For example, different Netflix users can have similar preferences. And then the anomaly detection, where we detect an unusual occurrence of a data instance in the data set. For example, credit card fraud detection based on the amount of money spent. Then we have feature scaling, which enables the gradient descent to converge at the center, and this is done by normalizing and also standardizing data. Then when do we do scaling? We usually do scaling while using machine learning algorithms that calculate distance of the data, then while using neural networks, while using the k nearest neighbors, as well as the PCA. And when do we not do scaling? This is usually done when algorithms are rule-based. Then we have the machine learning algorithm components, where we have the prediction model, cost function, and the optimizer. Then we shall look at the models, and the model is a representation of some phenomenon. We have the different types of mathematical and or statistical models, and these describe the relationship between variables. Here we will have the deterministic, where there is no randomness and it is suitable when the prediction error is negligible. For example, the body mass index. Then the probabilistic models, these are with randomness. For example, the systolic blood pressure of newborns, and it has mainly two components, which is the deterministic and the random error. And we have the types of probabilistic models, where we have the regression, correlation, and also other models. Then the main steps in regression, we have the hypothesizing deterministic components. The number 2 is specifying probability distribution of random error term, evaluating the fitted model, and finally using the model for prediction and also estimation. Then the machine learning algorithms perform well usually on unseen data, and here we have the methods used, such as the k nearest neighbors, and under here we have the parametric models, where you know which mode exactly you will fit to the data. For example, linear regression line, and this is our formula here for the linear regression line, which is y is equal to wx plus y plus e. Then the non-parametric models, here the data tells you what the regression should look like, and here y is equal to f of x plus e, and f of x is any given function. Then we have the IRIS dataset, which is a very classic, straightforward multicast classification dataset, and it has attributes such as the sepal length in centimeters, sepal width in centimeters, petal length in centimeters, and finally the petal width in centimeters. Then the KNN implementation, which is the k nearest neighbors implementation, we have to first calculate the distance between all the training data and then the test point using the Euclidean distance. Then find the nearest k neighbors by sorting through pairwise distances, and finally classifying the point based on the majority vote. we should never tune the hyperparameters using the test data. Then, cross-validation. The data set is randomly split up in 2 K groups, and one is used as a test and the rest used as training sets, and this method doesn't waste data. We also have the 2 different methods for measuring distances, and we have the Euclidean distance, which is used if the dimensions are measuring similar properties, for example width and height. Then the Manhattan distance is used when dimensions aren't the same. We have the K nearest neighbors case as well. We have the text mining, agriculture, finance and cargo competitions. Then the KNN pros, we have it is very easy to explain, simple to understand and extremely powerful, doesn't require any assumptions on the data distribution, and can be used for both regression and classification problems, as well as used easily with multi-class data sets. Then the cons are the efficiency of the algorithms declines very fast as the dataset grows, comes at a cost of making prediction step relatively expensive, suffers from skewed class distribution, as well as can't work if there is any missing values. Then the decision trees, here we have the Gini impurity, which measures the frequency at which any element of the data set will be mislabeled when randomly labeled, and this is calculated using a specific formula. And this we have the Gini index, which has values inside the interval of 0 to 0.5, whereas the interval of entropy is 0 and 1. Then the information gain is best for the attribute with many outcomes. Then the pros of decision trees, we have it is easy to interpret and visualize, has no assumptions about the distribution because of the non-parametric nature of the algorithm, then can easily capture nonlinear patterns, requires fewer data preprocessing from the user, that is to say there is no need to normalize columns, and can be used for feature engineering, for example predicting missing values. Then the cons, we have sensitive to noisy data, small variation in data can result in different decision trees, biased with imbalanced data set, therefore it is recommended to balance out the data set before creating the decision tree. Then the greedy algorithms do not yield global platinum tree structure, as also the branching goes deeper, you get exponentially less data. Then with ensemble learning, this combines many mediocre models in one super model, and here we shall see that there is bagging, which is a parallel tree grown with subsamples. It creates different models using different bootstrap training sets and average their predictions to produce the final output of the model. This bagging improves prediction accuracy at the expense of interpretability. Then we shall see the bootstrap, which addresses a very famous challenge in statistics, and the boosting is a sequential tree growing with weighted samples. Then we have the random forest, which is a slightly modifying bagging algorithms, and is a collection of decorrelated decision trees. The pros are robust to outliers, works well with nonlinear data, lowers the risk of overfitting, and it runs efficiently on large data set. Then the cons are it is biased while dealing with categorical data. Then pseudo training, not suitable for linear methods with a lot of spare features, and is greedy, and the greedy algorithms do not yield a global optimum tree structure. Then the strength of the K-means. The K-means is simple and easy to understand and implement. It is considered as a linear algorithm and is the most popular clustering algorithms, as the weaknesses are it is only applicable if the mean is defined, meaning if it isn't defined, it is not applicable. Then it is sensitive to outliers, it is sensitive to the initial seeds, and it is not suitable for discovering clusters that are not hyperellipsoids. We also have the principal component analysis, which is the PCA, and this is used to reduce the dimensionality of the data while keeping the information loss at a minimum. And the main applications of PCA are image compression, preprocessing step for classification, regression and clustering, then facial recognition, as well as the data visualization. That was all that I got to learn from the diploma.